Good morning, good afternoon, everyone. A warm welcome to all our attendees today from across the globe. Thank you so much for joining us for this webinar titled, Does Big Data Spell Big Costs? I'm Lisa Glenn, your host and presenter for today's session. Joining me today as the expert speaker is Robin Debnap, Big Data expert from the Impetus Labs. Now, in this 40-minute session today, we're going to share with you some of the best practices of lowering the total cost of ownership of your big data solutions. So let's go ahead and take a look at what today's session has in store for us. In our session today, we're going to be discussing some of the big data challenges that relate to the cost of big data solutions. We're going to identify some strategies that will help reduce that total cost of ownership, or TCO, as well as look at the technology options available to us now to achieve this feat. So let's go ahead and get started. On your screen coming up, you can have a look at some really interesting statistics around big data. You can only imagine how big the potential of big data is just by looking at some of these numbers on your screen. The IDC EMC actually estimates that the cost of computers, networks, and storage facilities that drive the digital universe is a whopping $6 trillion. And we actually spend an extra $650 billion US for the data that is really of little or no productivity. Now, this is due to just the overload of information and may add or accumulate to the cost of productivity and storage that eventually just goes to waste. Now, over the years, these numbers are likely to grow significantly. In fact, according to one study, the size of this data is actually likely to double every 18 months, which is amazing. Now, having taken a look at some of these sensational numbers, I think that we could all agree that this is obviously the age of big data. Now, just up until the recent past, businesses across the globe were only centered around writing and producing computing software. Big data has brought about really a paradigm shift affecting the way software is written. Big data is trending the industry around it, and again, today we are living in the age of big data. However, unfortunately, despite the fact that we have this rich pool of data at our disposal, we're still extracting poor information from it. And there's a lot more that can be done to unearth better and actionable insights and intelligence from it. So let's go ahead and see what solutions we have in place currently for cost-effective big data analytics. We're going to take a look at some of the pros and cons of those existing big data solutions, and we're going to start with commodity hardware. We think that really the biggest advantage of commodity hardware is that you can build it yourself. And in fact, there are many, many avenues open for innovation. Now, commodity hardware is readily available, giving people very easy access to it. So while using the commodity hardware, you actually have an option to customize, optimize, and really add your own touch over and beyond the existing offering. But as per our experience, that cost of building a reliable storage using commodity hardware may actually come up to be $1 per gigabyte. Now, remember, this is only for storage and does not include the cost associated with management, monitoring, and actually hosting of your big data. So what are those pros and cons of using open source and cloud computing? Let's go ahead and check some of those out right now. Now, of course, using free and open source software to store, manage, and analyze big data is a good idea. We all know that Hadoop can be leveraged to tackle large volumes of data while considerably saving on costs. Using that open source software with commodity hardware is really a match made in heaven because it provides you an affordable and highly available solution. So even in a scenario where possibly some nodes fail, the system just keeps running without compromising the data or the availability. Now, however, on the downside, there are some considerations while using open source software systems, such as training and support costs. Also, employees may need a certain degree of training in open source software to achieve the desired proficiency level that you're looking for. Now, support is another problem area, but you do have an option to engage third-party vendors to take care of this problem. But, of course, that would involve some costs as well. And now, let's go ahead and see if using cloud computing for big data is really a good idea or not. So one option that you have is that you can rent resources over the cloud to deal with your data and analytics. In fact, some prominent service providers that we can name here are Amazon Web Services and Windows Azure. You can actually select an offering appropriate to your specific needs and requirements from their various packages. And while you may think that storage over the cloud is an economical option, you might just want to think again. You actually may end up paying $14,000 a month for 100 terabytes. And remember, this is only for the storage. So having discussed some of the advantages and disadvantages of using commodity hardware, open source, and cloud computing for big data, we're now going to move on and discuss some of the cost components of a typical big data warehouse. The first element that we're going to consider now here is the entry cost. This is actually the cost that you're going to incur while experimenting with your data and just identifying whether a particular big data solution actually meets your requirements. So if that solution works, the next cost to you is migrating the data to that new system, especially the extract, transform, and load process, as the ETL process may require you to have an expensive specialized tool. Now, the other important cost component that comes into the picture now is performing analytics over the data stored within the system. And costs are also incurred over the manageability aspects because you would always want the system to be easily managed for scalability and failing conditions. Ongoing recurring maintenance is another really important cost factor that you really can't leave out. Your big data warehouse would always require monitoring and tuning as that data grows or perhaps changes are made. Now, with the huge volume of data deluge that we're experiencing nowadays, it's very likely that you would actually require additional hardware to cope with the increasing storage requirements and also for any additional computation and complex analytics. Also, industries may have to adhere to specific compliance guidelines, say an audit trail in the case of perhaps a healthcare domain. They're actually required to maintain several years of audit records, so that could possibly add to the cost factor as well. And while looking at all these factors together, you may get a little worried on how much you're actually paying for big data analytics. Well, we say don't worry. based on our extensive experience and expertise in big data, we have actually identified some best practices that can really help you in reducing that total cost of ownership of your big data solutions. Let's actually go through some of those now, and we're going to broadly categorize them on the basis of hardware and software. So where hardware is concerned, we suggest that you really keep the focus on costs incurred for storage and computation. Whereas in software, let's see if we can actually come up with some options that enable more processing with an overall lesser investment. Now, the challenge here is to speed up the things and also help reduce the cost. But before we do that and share those best practices of reducing the cost of storage, we'd actually like to ask you, our audience, a question. We would like to know, what is currently your biggest pain area? Now, the choices that you have are, 1, the high cost of commercial solution, the infrastructure cost, the cost of training and support, and finally, the cost of management. Now, on the right of your screen, you have a total of 30 seconds to answer that question right now. Okay, so we have most of those responses, and it looks like the majority of our audience is indicating that the high cost of commercial solutions is actually their bottleneck. Robin, can you comment on this?
Sure, Lisa. And hello, audience. I agree with the audience, as the cost of commercial solutions today is the area where most of the cost goes. Let's see if in the coming slides we can help you reduce that cost. Over to you, Lisa.
Thanks, Robin. Now, coming up on your screen, you're going to see some of the do's which can really help you reduce the cost of storage. So first, we advise compressing the data, as this is really going to help reduce the space required to store the data. Some solutions even claim to compress that data to its 1/40th. Now, however, you really need to ensure that the read throughput is not comprised when that data is decompressed. Let me just share with you another practice that can really help in reducing that cost of storage. If we take the example of memory or CPU architectures, we know that data flows from high latency to low latency memory, which is very near to the CPU. Low latency stores are usually really expensive, and in order to keep that cost low, we can employ a mix of high latency and low latency stores. You can actually picture it as a pipeline of data where that data flows from the expensive high latency data store to the expensive low latency store. Now, we can easily reuse this strategy in our big data scenario. And when analytics comes into this picture, it actually may not be required to bring in the entire data that we've accumulated over a certain number of years. We may actually opt to run analytics over just some specific set of data. Therefore, instead of retaining each bit for processing, we can choose to load only the required data and then process it. We believe that we can set up similar data pipelines in our big data context. Now, we can also create appropriate systems to store data and information based on the principles very similar to information lifecycle management. Now, ILM is not a new term or a practice, and the question is, can we use the same ILM principles for structuring and administering of our big data? Now, let's move on and talk about small data, which is another really important factor. we would actually not recommend using the big data solutions for storage and retrieval of a small amount of data, as the relative latency will be higher for the fetch. We actually believe that better insights and more conclusive drawings can be made over a small set of data. So basically our advice to you will be, do not take your eyes off from that small data, as it's really very important too. And now let's go ahead and move on to discuss reducing the cost of software. One of the key considerations that's really going to help you reduce the total cost of ownership, or TCO, is to understand all the technologies available to you and where they can be used. Let's go ahead and take a closer look at this. There are a lot of commercial solutions that you can choose from, or alternatively, opt for those open source solutions. So with the commercial ones, you are befitted with just a rich tool set to set up and configure your big data system, as well as that important customer support. Now, on the other hand, if you want to save costs, you can opt for the open source technologies. With that advent of big data, several commercial specialized hardware and appliances have come into existence, and they really offer rich features such as fault tolerance, easy capacity scaling, specialty management tools, and so on. The commodity hardware available to us today can be harnessed for those big data use cases by leveraging those open source stack or solutions. Now, another important consideration is really whether you are dependent on your vendor for their products and services. In a big data scenario, if you have agreed to a vendor lock-in, you actually may have to incur a substantial cost in order to make the switch. However, vendor-independent systems leave a lot of room open for innovation. Latency is also a really critical factor, and the systems with lowest latencies, unfortunately, are likely to be expensive. Now, there is a specific niche market that tackles the latency as its actual business problem. You may also have considered the cloud as a potential solution to move your big data. However, you need to ask yourself, is moving to the cloud the only solution for your data storage requirements? Because they can be expensive, especially when the data is not already on the cloud. In such a scenario that you're going to have to upload the entire data required for processing, thereby adding to your cost. So having covered the what technologies portion, I would now just like to take you through the where to use these technologies portion. You can broadly classify this among two categories where the data flow and processing is observed. One for online analytical processing, and the other for online transaction processing. So don't worry if you're generating or working with large sets of data in your OLTP scenario. The cost-effective NoSQL solutions really come to the rescue here. On the other hand, in a typical data warehouse scenario which requires analytical processing, MapReduce or MPP-based systems are used. Let's now look at the possible big data scenario where we largely deal with analytical processing. Online analytical processing with respect to big data can be categorized into three categories that you actually see on your screen right now. The first one on top there is the most common, and it's big input, small output. This is used to draw conclusions and to prepare graphs or charts or perhaps in scenarios where the top N elements in a data set are to be identified. Now, the next possibility that you see is when our input set of data is small and the result is big output. This typically happens in case of predictive analysis where N number of outcomes is possible. It's also applicable in scenarios where the correlation coefficient matrices are required to be populated with a given set of input that could be small, but the result set values might turn out to be very large. The last possibility here that we observe is a big input and big output in process of ETL that is extract, transform, and load. Now here, the magnitude of output data is similar to that of the input data. Now, the image that you see on your screen right now presents a view of some key parameters such as data volume, data summarization, latency, and the cost with respect to the scale of data that we see today. Now, the tapping points at the bottom indicate the amount of data flow with each of those various systems. And you can see here that Hadoop is at one far end with a large volume of data. Then as you move to the right, you see that the massively parallel processing systems, where they cater to a relatively smaller size of data vis-a-vis Hadoop. And then toward the right is the stack of relational database management systems and NoSQL database solutions. In a real-world scenario where we're actually performing summarization or concentrate data with respect to some parameters, there is a decrease in the data volumes. The recommended system operating on lesser volume of data is the small data solutions such as MPP, then traditional RDBMS, or the newer NoSQL databases. These systems actually offer the lowest latency in such a scenario. Now, whereas if we move from lesser amount of data to big data, that is from the right to the left as per the image on your screen, the latency of systems increase, and also there is a decrease in the cost per gigabyte. Now, we all already know that Hadoop systems are very cost effective. However, in case of small data solutions where latency is really the key factor, it's actually better to opt for customized and tailored solutions that are able to enable quicker retrieval of the data. However, their deployment would take the storage cost per gigabyte on the slightly higher side. MPP, on the other hand, benefits from both of these sides. And while one may look at the cost factor, there's enough reasons for a warehouse to use MPP solutions. These systems can provide you with relational stores while at the same time they can also accommodate larger sizes of data. In a typical scenario, you may actually need to deploy all or possibly a combination of these systems at the same time. So let's go ahead and check some of them out now. If you have a look on your screen, in this approach that you see, we're using Hadoop for cleaning and transforming the data into a structured form, and then we're loading the same into the RDBMS databases. We can now use any existing visualization techniques or tools from the rich world of RDBMS visualization products. Thus, that visualization phase is handled by your existing tool sets. Hadoop can efficiently access that data between the RDBMS data sources and Hadoop systems through DBI input format and DB output format interfaces. So once the unstructured data is processed, it can then be pushed to an RDBMS database, which can subsequently act as a data source for any BI solution. This approach is able to provide the end user with that flexibility of parallel processing of Hadoop and the SQL interface at the summarized data level. Now, it's pretty good when the summarized data is not too big a problem to pose a challenge for the RDBMS database being used. This solution is not very expensive, especially in relation to some of those other options. This approach is also very suitable for the high-touch queries, where perhaps the user wants to perform real-time ad hoc analytics, as most of the RDBMS databases come with a comprehensive set of performance enhancement techniques. So the question now is, what happens if you plan to apply analytics directly over a Hadoop system without moving it to any RDBMS databases? And let me explain this again with the help of the diagram that you can now see on your screen. It can prove to be a very effective practice to analyze the data from the Hadoop file system. Say perhaps we have a scenario where the processed and summarized data, which in itself is very huge, is placed onto the Hadoop system. So the question is, what do we do in a situation where we want to use the summarized data for batch reporting without getting into the complications of moving the data out of the Hadoop system either to an MPP data warehouse or RDBMS? In this case, we suggest that you use Hive because it really provides a very promising interface for executing the SQL-like queries by converting them into MR or MapReduce jobs. These MR jobs are executed on the Hadoop clusters for the data that is itself present on Hadoop. This approach allows you to do batch and asynchronous analytics over the same data present in the Hadoop system. And it's really a very cost-effective approach because it doesn't involve any expense in managing the separate data sources other than your existing Hadoop system. In addition, it also provides you with that important flexibility of scaling to any level with your summarized data. Now, today, there's just a lot of options available in the market that allow integration of MPP data warehouses with Hadoop. And it's really worth considering if you have a large amount of data, even after applying summarization over it. Using Hadoop for cleaning and transforming the data into a structured form allows you to load that data into any of the available options of MPP DWs. Now, while that data is being uploaded, you may choose to write user-defined functions to perform database-level analytics and then integrate the same with BI solutions using ODBC, JDBC connectivity for end-user analytics and reporting. Also, using MPP data warehouses will allow you to use various performance enhancement techniques, for example, like index compression, materialized views, result set caching, and I/O sharing. Now, however, there is a disadvantage here of using this approach, and it would be the cost that's involved in it. Most of the MPP DWs are very expensive to acquire, and some actually also require high-end servers for deployment, which again would be a costly proposition. So having discussed the big data strategies that we can adopt to reduce the total cost of ownership, I'd once again just like to talk about what technologies to use and where to achieve this purpose. So, we've already established that selecting appropriate technologies can significantly help reduce the TCO of big data solutions. But before we advise you on how to choose the correct technology stack, I'd just like to share these 3 considerations with you. And for each, you really should ideally check if your use cases can be implemented or not. So the first consideration for you is, what is the cost you are shelling out for per terabyte of storage? Does it impact your business with the amount you're spending over per terabyte, considering the contract license? The next consideration for you is the cost related to business continuity. What about vendor locking? Is your system likely to change due perhaps to some strategic decisions, and you might actually have to switch over to a different vendor? So if your requirements are volatile and the data or related strategies are likely to change frequently, then perhaps working with a vendor lock-in model would not be a good option for you. So the next factor you should consider is your latency requirements. Is your use cases complete with respect to the throughput of the system? So if you have a system for the not so large data and you're very critical with the response of the system, MPP or RDBMS systems would actually be a probable choice for you. Now on the other hand, if you can live with higher latency of your large data, you can go ahead and stick with the Hadoop-based systems. I'd now like to just ask Robin to share a few more insights about this. Robin?
Sure, Lisa. And hi again. So when your use case is driven by the dollar per terabyte factor, we advise you to go for MPP solutions. We offer a middle way to the Hadoop and NoSQL-based solutions and can store large amount of data without compromising the speed. However, they are expensive and the cost will increase exorbitantly if you want to cater to all of your large data. There are various options available to you to choose from, and each has its own set of pros and cons. On your screen, you can see some of the popular vendors providing MPP solutions. And of course, each one of them has a different dollar per terabyte cost. If your use case is driven by cost or business continuity, we advise you to opt for Hadoop. Hadoop would allow you to store all of your data, but unfortunately has a relatively higher degree of latency. Few vendors have come up with faster Hadoop implementations or other parallel processing frameworks. Their solution usually extends standard Hadoop APIs and offer enhanced system performance, as well as provides better support for production environments. Check out the list of well-known vendors in this space on your screen. So, in an OLTP scenario, you require faster read and writes. Vendors here in the list have different kinds of underlying implementations. Each one is suited for a typical business use case. Say, if you require random and real-time read-write access to the big table-like data, you can use HBase. Whereas if you require faster write, you might want to check Cassandra. These are suited in industries like banking and finance. In case if your transaction data storage requirement is mostly for query purposes and you have requirement of defining indexes, you can use MongoDB or CouchDB. there are other databases as well, say graph databases like Neo4j and many more, which allow the current big data social media analytics problems to be solved more easily. So why new era RDBMS for OLTP? Because it addresses the latency issues. In the OLTP scenario, people have been using SQL successfully since last so many years. Most of the business users still consider it as the best tool to query structured data. But now, there is a new emerging set of technologies or new version of existing RDBMS engines which are adept in handling large volume of structured data. So in a scenario where you want to handle larger volumes of data and the data is in structured format, then you can use solutions such as MySQL cluster, GridSQL, or maybe the new version of MS SQL, and so on.
Thanks, Robin. That was really helpful. So let's now just take a quick recap of all of our recommendations. On this slide, I'm going to share with you how to deal with the various cost components associated with a typical big data warehouse. Let's take up the first problem, which is how to deal with the entry cost or cost of experimentation. Our advice: follow those best practices. You may also choose to learn the new technologies or, alternatively, bring in the experts. Now, for the cost of moving data, we suggest opting for MapReduce for ETL or ELT instead of using those costly ETL tools. Management and provisioning tools are available with the commercial big data solutions for easy management of the systems. In fact, Impetus is offering Ankush can automatically provision multiple Hadoop clusters, and it also offers centralized management for these clusters. Now, for ongoing maintenance, our success mantra is automate, automate, automate. If there is a requirement to carry out any task more than once, just automate. Now, this also goes for monitoring and tuning too. Now, one last question you have to ask yourself is, how do we deal with the changing capacity? Should we just keep on adding hardware, or perhaps look for alternatives that can help speed up things? Utilization of graphics processing units for general purpose computing may help in this situation. So, continuing on with our recommendations for reducing the hardware and software costs, Rainstor and related solutions would help compress the data here and enable you to reduce the cost of hardware required for storing the data. Faster, more tailored MapReduce solutions will help you complete more tasks in lesser time. So it actually looks like we have started to receive some questions from the audience. And we'd just like to remind you that you may use the chat panel to ask those questions right now. But before I take up some of those questions, I'd just like to quickly introduce Impetus Technologies. Impetus is a leading technology and R&D services provider, and we have a strong focus and established thought leadership in the area of large data analytics and high-performance computing. We built top-tier expertise and offer consulting and professional services in technologies like Hadoop, numerous NoSQL databases including Cassandra, MongoDB, Membase, and a whole range of commercial MPP products and ETL BI analytics tools. Our expertise really spans the domains of large data management, cloud computing, data analytics, mobile, SaaS, testing, social media, web technologies, performance engineering, open source, among others. And I'd also like to share with you about the Impetus Big Data Quick Start Gear Up to the Summit program. Now, this is actually designed for companies trying to embrace the big data technology paradigm to achieve those next generation business insights from their ever-growing data. This program leads businesses and IT executives through a very methodical approach to address their big data analytics challenges. So it looks like it's time for those questions now. And we've received some great questions. The first one that someone asked is that there are a lot of Hadoop variants available in the market right now. So how should I choose one? Robin, I'm going to ask this to you. What do you think?
Yes, so some of the important decisions that can actually affect your choice of Hadoop distribution could be vendor lock-in or compliance with open source Apache. For example, the MapR has its own implementation in NFS. Cloudera is more or less closer to Apache Hadoop, but has its own distribution. Using the HPC is alternate mechanism altogether. Some of the MPPs also provide in-data MapReduce, which is different from Hadoop MapReduce. So I would say like cost is one, vendor lock-in is one, compliance with open source APIs is also there. Well, performance is another aspect, and some of the Hadoop distributions claim to be better performing.
Okay, great, Robin. Someone else actually asks, they say, I have a real-time analytic requirement. Can it actually be part of your big data model? And if so, how can I reduce the cost? What do you think?
Well, we are seeing that real-time analytics is now becoming a recurring requirement in the big data world. There are again hardware and software solutions available for solving real-time analytics. These also offer compatibility with big data technologies. Open source solutions like the Apache Lucene, Apache Solr, or Yahoo S4 can be used for building real-time capabilities for big data.
Okay, great answer. And it looks like somebody else would like to know, for big data is only MPP or Hadoop solutions, is that the only solutions, or are there other alternatives to them? What do you think?
MPP and Hadoop are basically meant for OLAP solutions. Our first suggestion to customers would be that they should move to MPP and Hadoop only when they have a big data problem. RDBMS solutions are good for smaller sets of data, but if you do not have large data, do not go for these solutions. Secondly, as mentioned earlier, we talked about new era RDBMS as well. So they have kind of progressed or have provided solutions which can quite fill in the gaps of existing RDBMS solutions. And HPCC could be an alternative that offers another MapReduce implementation altogether.
Okay, another question that someone would like to know the answer for is, what tools for analytics can I use over Hadoop to save my cost? Robin?
Yeah, so most of the leading BI vendors actually provide some of the other kind of integration over Hadoop. Mostly these solutions use Hive as an interface, and of course you can directly use Apache Pig and Apache Hive for analytical as well as ETL processing over Hadoop. Intellicus, our sister company, also has support for big data, where you can actually drag and design reports over Hive.
Okay. Looks like we have another question here, and someone would like to know, what are the ways of compressions used in Hadoop? Robin? Well,
Hadoop already has support for compression. you can actually choose from various flavors that are available to us. Options to your dispense could be LTO, GZIP, BZIP2, and some of the options available are not parallel friendly. If I take example of LTO, it offers compression with splits, and the beauty is that it makes it to be parallel friendly. Well, Hadoop Snappy is another compression that is picking up. It is easy to use and is noticed to be faster than others. Beyond Hadoop, also there are commercial systems available which offer compression up to 40 times. As discussed earlier, these are specialized software solutions like Rainstorm, which actually provide greater amount of compression.
Thanks, Robin. Thank you to everybody. Unfortunately, that's all the time we have to answer the questions live, but we will be addressing all the remaining questions that we've received through an email to you. I'd just like to take a moment to thank you all for your time today, and we really hope that this discussion was a learning experience for everybody and will add true value to your big data initiatives. Now, if you have any other questions, please feel free to email us at inquiry@impetus.com, or you can visit our website, bigdata.impetus.com. I'd also like to inform you that we're actually going to be sponsoring and exhibiting at the Cloud Expo. Please write to us if you want to obtain a free pass for that expo. Once again, thank you so much for joining us in this session today. Goodbye.